Scientists have always treated the Milky Way as a stable, well-behaved galaxy where violent cosmic events were rare and predictable. Our galactic center was supposed to house a dormant supermassive black hole that occasionally consumed small amounts of matter, but posed no threat to the galaxy's overall structure. Astronomers mapped our cosmic neighborhood with confidence, believing they understood the major forces and structures that shaped our galactic home. But the Fermi Gamma Ray Space Telescope just revealed something that rewrites everything we thought we knew about our galaxy's capabilities. Extending 25,000 light-years above and below the galactic plane are two massive bubbles of superheated gas emitting gamma radiation so intense it can be detected from Earth despite being thousands of light-years away. These structures are colossal, and they changed our view of the Milky Way. These structures are so colossal that they contain enough energy to power our entire civilization for billions of years, yet they remained hidden until 2010 because they emit radiation invisible to optical telescopes. Here is the catch that is keeping astrophysicists awake at night. The bubbles show evidence of recent formation, suggesting they were created by a catastrophic explosion at our galactic center within the last few million years. The energy required to create these structures exceeds anything we have observed in galactic physics, implying that our supposedly stable Milky Way is capable of violence on scales that dwarf supernovas and gamma-ray bursts. The discovery forces us to confront a terrifying possibility. If our galaxy can produce events powerful enough to create structures 50,000 light-years across, what other destructive capabilities are hidden in the cosmic systems we depend on for stability? These bubbles might be evidence that galaxies operate on cycles of catastrophic activity that could reshape or destroy entire stellar regions without warning. Watch until the end to uncover why this discovery suggests our cosmic neighborhood is far more dangerous than we ever imagined, and what the existence of these enormous energy structures might mean for the long-term survival of everything within our galactic vicinity. The Fermi Gamma Ray Space Telescope launched in 2008 with a mission to map the universe's most energetic phenomena. Unlike optical telescopes that see visible light, Fermi detects gamma rays, the most powerful form of electromagnetic radiation, produced only by the most violent cosmic events. Dr. Doug Finkbeiner at Harvard University led the team analysing Fermi's data from our galactic center. They expected to see the familiar gamma ray glow from cosmic ray interactions, and perhaps some activity from Sagittarius A star, our galaxy's central black hole. The region was supposed to be relatively quiet, compared to more active galactic nuclei in distant galaxies. For 2 years, the team processed data showing the expected background radiation and known gamma-ray sources. The galactic center appeared normal. It was active enough to be interesting, but not dramatically different from theoretical predictions. In 2010, when Dr. Finkbeiner's team began creating detailed maps of the gamma-ray sky, they noticed something that shouldn't exist. The data processing algorithms kept flagging massive structures extending far above and below the galactic plane. Initially, they assumed these were data processing artifacts or instrumental errors. Gamma-ray astronomy was still relatively new, and false signals were common. But as they refined their analysis, the structures became more defined, not less. They were looking at something real, something enormous, and something that challenged every model of galactic structure they had studied. The first anomaly appeared when the team processed gamma-ray data from the galactic center region. Instead of the expected smooth distribution of radiation, they found two massive lobes of intense gamma-ray emission extending symmetrically above and below the galactic plane. Each structure measured approximately 25,000 light-years from the galactic center to its edge. To put that in perspective, these bubbles were larger than the distance from Earth to the galactic center. They were among the largest coherent structures ever discovered in our galaxy. But here is the catch. The bubbles were completely invisible to every previous astronomical survey. optical telescopes, radio telescopes, and X-ray and X-ray observatories had never detected any evidence of these massive structures. They existed only in gamma-ray wavelengths. The team recalibrated their instruments and reprocessed the data multiple times. The results were consistent. Two enormous bubbles of gamma-ray emitting gas were extending from our galactic center, containing more energy than millions of stars. It gets more disturbing. The gamma-ray spectrum of the bubbles showed they were composed of extremely hot, ionized gas, moving at velocities of millions of miles per hour. This was not a static structure. It was expanding debris from a massive explosion. Dr. Finkbeiner's team faced an impossible astrophysical puzzle. The energy required to create structures of this size exceeded every known mechanism for galactic center activity. Even the most active supermassive black holes in distant galaxies did not produce comparable features. The team analyzed the gamma-ray spectrum to determine the bubble's composition and energy source. What they found was unprecedented in galactic astronomy. The radiation signatures indicated temperatures of millions of degrees and particle energies that could only be produced by catastrophic cosmic events. Here is the deal. The bubbles showed clear evidence of recent formation. The sharp edges and uniform temperature distributions suggested they were created by a single massive explosion rather than gradual accumulation over cosmic timescales. But the energy calculations were staggering. Creating these structures would require the equivalent of millions of supernovas exploding simultaneously, or the sudden activation of our galactic center black hole at levels never before observed. The team realized they weren't just looking at unusual galactic structure, they were examining the aftermath of one of the most powerful explosions in our galaxy's recent history. The third mystery emerged when the team analysed the bubble's expansion patterns and age estimates. The structures showed evidence of ongoing expansion, with material still moving outward from the galactic centre at tremendous velocities. Based on the expansion rate and current size, the team calculated that the explosion that created the bubbles occurred between 1 million and 3 million years ago, extremely recent in cosmic terms. This meant the event happened during the era when early human ancestors were developing on Earth. But here is what made this discovery genuinely terrifying. The explosion was powerful enough to affect the entire galactic environment. The bubbles contained enough energy to disrupt star formation, alter cosmic ray distributions, and potentially sterilize planets within their influence. The team found evidence that the explosion had launched material completely out of the galactic plane, creating structures that extended far beyond the Milky Way's normal boundaries. This suggested that our galaxy was capable of violence that could affect intergalactic space. The implications were staggering. If our supposedly stable galactic center could produce explosions of this magnitude, what other catastrophic capabilities were hidden in the cosmic systems we depended on for stability? The Fermi Gamma Ray Space Telescope represents the cutting edge of high-energy astronomy. When it detected the bubbles, it was not making subjective interpretations. It was measuring precise gamma-ray emissions from specific regions of space. To put that in perspective, detecting gamma rays from 25,000 light-years away requires sources with energy outputs comparable to the most violent phenomena in the universe. The bubbles were emitting radiation equivalent to millions of stars worth of energy. The Harvard-Smithsonian Center for Astrophysics confirmed the findings through multiple independent analyses. Different research teams using different data processing methods all identified the same massive structures. They ruled out instrumental error because the bubbles appeared consistently across multiple observation periods and detector configurations. They also ruled out foreground contamination because the gamma-ray spectrum was consistent with hot gas at distances from the galactic center. Dr. Finkbeiner's team analysed the bubbles' gamma-ray spectrum to determine their physical properties. What they found was unprecedented in galactic astronomy. The radiation indicated gas temperatures of 10 million degrees Kelvin and particle energies that could only be produced by cosmic ray acceleration in extreme magnetic fields. The morphology analysis revealed that the bubbles had sharp, well-defined edges and uniform internal structure. This indicated they were created by a single, coherent explosion rather than by gradual accumulation of material over time. Professor Meng Su, a co-author of the discovery paper, confirmed that the bubble's energy content exceeded 10 to the 55th power ergs, equivalent to the energy output of our Sun over its entire 10 billion year lifetime, released in a single event. The expansion velocity measurements showed material moving at speeds of 1,000 kilometers per second, fast enough to escape the galaxy's gravitational influence and to affect intergalactic space. The first suspect was instrumental error, or data processing artifacts. Gamma-ray astronomy involves complex data analysis, and false structures can appear when processing algorithms misinterpret background radiation or cosmic ray contamination. But the data showed clear contradictions to this theory. Multiple independent research teams, using different analysis methods, all detected the same structures. The bubbles appeared consistently across different observation periods and energy ranges. With instrumental error ruled out, scientists had to consider more exotic possibilities. Some proposed that the bubbles were created by a massive star formation event or a series of coordinated supernova explosions in the galactic center. The most disturbing idea is the black hole outburst hypothesis. This proposes that Sagittarius A star, our galaxy's central black hole, underwent a period of extreme activity that launched material at relativistic speeds across galactic distances. Dr. Finkbeiner and his team proposed that the bubbles were created by a massive outburst from Sagittarius, a star that occurred 1 to 3 million years ago. During this event, the black hole would have consumed large amounts of material and launched powerful jets of plasma into space. But here is the catch. This theory requires accepting that our galactic center black hole is capable of activity levels that exceed anything we have observed in similar systems. The energy output would need to be comparable to the most active quasars in the distant universe. Some researchers have proposed even more radical explanations. The bubbles might be evidence of dark matter annihilation, exotic particle interactions, or unknown astrophysical processes that operate on galactic scales. The implications are staggering. If our galaxy can produce energy events of this magnitude, it suggests that galactic centers are far more volatile and dangerous than we've ever acknowledged. The discovery of the Fermi bubbles proved that our understanding of galactic physics and cosmic stability is fundamentally incomplete. These structures represent evidence of catastrophic violence in our cosmic neighborhood that we never knew existed. This means our supposedly stable galactic environment is capable of producing energy events that dwarf supernovas and gamma-ray bursts. The explosion that created these bubbles released more energy than our Sun will produce in its entire lifetime. But the question that haunts astrophysicists is deeper. If our galactic center can produce explosions powerful enough to create 50,000 light-year structures, what other catastrophic capabilities are hidden in the cosmic systems we depend on? Are we living in a galactic environment that undergoes periodic cycles of destruction and creation? Do the Fermi bubbles represent evidence that our galaxy operates on cycles of catastrophic activity that could threaten every star system within tens of thousands of light years? Or is there an undiscovered astrophysical process that can explain such massive energy structures? What if this discovery is proof that our cosmic environment is far more volatile and dangerous than we have ever imagined? What if galaxies undergo periodic explosive events that could reshape or sterilize vast regions of space, including areas containing habitable planets? The bubbles might be evidence that our understanding of galactic physics and cosmic safety is dangerously incomplete. If that is true, then we need to reconsider our assumptions about the stability of our cosmic neighbourhood and the long-term prospects for life in our galaxy. Let me know your theory in the comments. If you want to keep exploring the discoveries that are rewriting our understanding of cosmic physics, subscribe for more galactic mysteries that challenge everything we thought we knew about our place in the universe.